And then, what would you do to start solving that equation? I look for new ones. New, more exciting. Okay, tell me, what kinds of things did your group say you were going to do? Yeah, probably add 1 over to the other side. Okay. So then we would get the cube root of 2x minus 9 equals what? 3? Did you guys talk about doing anything else? Take the cube root of both sides? What does that look like? Okay, this side already has a cube root, doesn't it? So do I really want a cube root? No, what's the opposite of a cube root? Cube. So rather than cube root both sides, I would say I want to cube this side, because what's going to happen to a cube root cubed? Cancels each other out. That's like 3 over 3 as a fraction exponent, so to the first. And then I just have to do that to the other side as well, right? I'm allowed to do that. So this stuff cancels out. I get 2x minus 9 equals 3 cubed is 27. 3 times 3 times 3. And then is that an equation you could solve? Add 9. So 2x equals what? 36. Divide by 2 and x equals 18. Now let me ask you this question. How do you know if you're right? Plug it back in, right? You could do a check. Okay, so is the cube root of 2 times 18 minus 9 and then minus 1 really equal to 2? Ask that question. Well, you'd work it out with order of operations. So you got to do like parentheses first. Anything that's under a radical is kind of like a set of parentheses. So I would do 2 times 18, which is 36, minus 9, which will get me 27. So the stuff underneath the radicand is 27. And then minus 1 equals 2. And sure enough, the cube root of 27 is 3. 3 minus 1 equals 2. Yeah, it checks out. Right? 2 equals 2. Okay. So basically, what you described to me, and if you want to jot some of this down, you can. First, you isolate the radical. Like, you get the radical all by itself, the nth root. That could be a cube root, could be a 4th root, a 5th root. And then this is where, like, maybe it's a new piece for us because we've really only probably worked a lot with square root equations before. Instead of nth rooting both sides, because one side already has an nth root, we had a cube root over here, do the inverse operation, which is raise each side to the nth exponent. So if you have an nth root, you need an nth exponent to get rid of it. Okay? And then solve like normal. Something that's going to pop up for us with even roots is some solutions that we think are right may not work. Those are called extraneous solutions. Have we talked about the word extraneous before? Okay, that means that it's a false solution. It looks like it should work all of our algebras correctly, but when we plug it back in because of an even root, something isn't right. So it's always important for you to check your answers at the end. Okay, so let's look at this one. Square root of x plus 25 equals -2. Talk with your group members and solve it. What do you think you're going to do? Square root of x plus 25 equals -2. Okay, let's talk. You know, in the last slide I said, like, try to isolate the radical, get the root all by itself. Is there anything that we can move away from the square root right now? No, everything is trapped underneath the square root, so I can't subtract 25 because it's protected by the radical. So the radical is really isolated all by itself right away. I'm just going to start by undoing a square root. To undo a square root, square both sides. So I'm going to square the square root on the left, and this is going to be really important. I have to square the whole right side. So in this case, I'm squaring all of -2, so I'm protecting it with a set of parentheses. Okay? If you have stuff that's like being added or subtracted over here, you should do the same thing, like put a set of parentheses around it and then square it. Okay, that gets me x plus 25 equals -2 times -2 is 4, and then x equals -21. Now, how do you know if you're right? You do a quick check, right? So if I put in -21, -21 plus 25, is that equal to -2? Isn't that the square root of 4? Here's where things get a little bit weird. When you're doing this check and you see like a square root of 4, if I just asked you out in the normal world, what is the square root of 4? You would tell me 2. You would just answer 2, wouldn't you? Okay. So this is called simplifying. When you simplify a root, you always say the positive root. It's called the principal root. So the square root of 4 is always 2. Is 2 equal to -2? No. Therefore, -21 is what we call extraneous. Long word. Okay, that's an extraneous solution. And extraneous really just means false. But we're going to hear that later on in second semester. We're going to have other cases of extraneous solutions. This is different than wrong. -21 isn't wrong. It's right. We did the math correctly. Everything we did was allowed. Okay? It's just saying that when you do all your algebra correctly and you put it back into the equation, it doesn't work out that both sides are equal. So it's a false solution. Okay? That happens when, if you look back at the original equation, you can kind of sort of start to get a feel for this. Notice that I'm taking an even root, a square root, and the square root is equal to a negative number. But a square root, if simplifying, will always just assume the principal root, which is the positive root. Now, I know that when we're solving, we put the plus or minus, right? But that's different than like simplifying a square root. Okay, so I'm not solving right here. I'm just simplifying this side. Okay, so there is a difference. Because my only solution was extraneous or false, my final answer is there's actually no solution. Negative 21 was the only x that would have worked, but it doesn't work. And we can tell by going back up to this very first part, we knew we were going to get a false solution because we were taking an even root that equaled a negative number. And an even root wouldn't simplify to be negative. It'll simplify to be positive. Okay, so we're going to let that sit for a little bit. Okay, talk to your groups real fast. What are you going to do for the square root of 2x plus 5 equals the square root of x plus 7? Tell your group members what you're going to do to solve. Well, I got a square root on the left, and I got a square root on the right. There's really nothing left for me to do but undo the square root. How do I undo a square root? Square both sides. Okay, if I square a square root, that'll cancel. I'll get 2x plus 5 equals x plus 7. Is that an equation you can solve? Yes, you've been solving those since Algebra 1, maybe a little bit before that even. Get x's on one side, get numbers on the other. So I'm going to subtract x from the 2x, which will get me 1x. I'm going to move the 5 over to the other side, so x equals 2. Now, as you do your homework, remember that you should also be checking your answers. So I'm writing down my checks. Sometimes you might be just checking them in your head. So I'm going to put this in a thought bubble, like I'm just thinking about the two sides. Okay, and I'm going to put 2 in right here. That's going to be 2 times 2 plus 5, which is 9. Over here, that's going to be 2 plus 7, which is 9. Are the two sides equal? Yeah, the square root of 9 is equal to the square root of 9. It works. Let's see. I always have that trouble where I can't get to my end. Am I close? Where's that little x? Help me out. See it over there? Am I close? On the side?
Okay. Keep going to the right. A little farther.
Oh my god, it's like torture. Oh, there. Yay. Okay. All right. I would definitely put this example in my notes. Of all the square root, cube root, fourth root, fifth root problems, this is the one that maybe is the most difficult. It's not that difficult, but it's maybe the most difficult one. Now look back at our other examples. All we really had to do was isolate the radicals and then square both sides or cube both sides. Okay, and of course check our answers. Okay, we've got x plus 1 equals the square root of 7x plus 15. I notice, of course, that there's a square root in my equation, so that means at some point I have to square both sides, right? My job is to isolate the radical before I do that. So is there anything on this side with the square root that I can move over? No, 7x plus 15 is all trapped underneath the radical. It's part of the radicand, so it is stuck there. Okay, x plus 1, I don't really want to move anything over to the other side. I want that radical to be all by itself. So we're going to do just like we did on the last one. We're going to start by squaring both sides. I'm going to square the square root. And then remember what I said back when I had that -2 that we want to square the whole other side. So we're going to put this in parentheses. Okay, what does x plus 1 quantity squared mean? Take x plus 1 times x plus 1. Take it times itself, right? To square something is to multiply it by itself. So this side is expanded, x plus 1, x plus 1. This side over here just cancels out. Okay, so it's just 7x plus 15. And I'm going to FOIL out x plus 1, x plus 1. That's what? X squared plus, check your outsides, insides, 2x plus 1 equals 7x plus 15. I'm going to put it over here on this sideboard, but this is wrong. This is my most common wrong answer to this problem. So they square both sides. Imagine if you could see yourself doing this. X squared plus 1. Could you see yourself doing that? Just squaring the x and squaring the 1 and calling it good? Distributing the square over to plus or minus? Okay. Don't want to do that. That's not a property. Okay. X squared plus 1 is not the same as x plus 1 quantity squared. Okay. So this is the most common bad answer. Okay. So if it helps you, write it out in expanded form and FOIL it. There should be a middle term. Okay, how do you solve an equation if you have an x squared and an x in it? Maddie?
You factor.
Yes, we'd like to factor it. Before you can factor, one side has to be equal to 0. So I always like to keep my x squareds positive, so I'm going to keep everything over here, and I'm just going to subtract 7x and subtract 15. So I get x squared minus 5x minus 14 equals 0. You factor that? Factors to negative 14 that add to make negative 5? Negative 7 and positive 2. And so my x's are positive 7 and negative 2. Okay, everybody okay with that? Anybody got any questions for me? What should we do? We should check our answers. This means we have 2 answers to check. Okay, so I'm going to scroll up here. It's what? X plus 1 and the square root of 7x plus 15. X plus 1 equals the square root of 7x plus 15. Okay, so I'm going to do a check for x equals 7, and then I'm going to have to check x equals negative 2. Okay, and again, I'm going to kind of do this more like in my head now, so I'm just kind of like thinking about it. 7 plus 1 would be 8 on the left, and then if I do 7 times 7 under the radical, that's what, 49, and 49 plus 15, that'd get me to 59 plus 5, which is 64. So does 7 work? 8 equals the square root of 64? Yep. Okay. Let's check negative 2. Negative 2 plus 1 is negative 1 on the left. And then we're going to have the square root of, this is negative 14 plus 15, which is 1. Is the square root of 1 equal to negative 1 in the check? What is the square root of 1? 1. When I just ask you, right? When I just say, like, out in the random world, what's the square root of 1? You just say 1. You don't say plus or minus. We do that when solving. Okay, so we don't know if it was positive times positive or negative times negative. But normally we would just say the square root of 1 is 1. So does x equals negative 2 work? No. Square root of 1 is not negative 1. The square root of 1 should simplify to be 1. This is bad. This right here is x radius. EXT. So I'm going to cross off negative 2, label it EXT. The only answer is x equals 7. Okay. So remember, we're seeing that same thing that I described. A square root won't equal a negative number when simplifying. When we simplify a square root, we use the principal root, which is the positive root. So if you know that one side is equal to a negative and on the other side it's a square root, or I should say an even root, then you know it's an extraneous solution, because the even root will always simplify to the positive. Now an odd root would be okay, right? We could do like a cube root of -1. It really is -1, because they only have one answer. Okay. What if you have a fraction exponent instead of a radical? We'll do a few examples, and then you'll have some work time. Basically, the rules are still the same. I say isolate the fraction exponent and its base. That's like basically the radical part of it, right? Okay, so whatever the fraction exponent is touching, okay, isolate that. The one thing that's different is here in blue. You know, if you leave it in rational exponent form, if you don't change it to a radical, then all you have to do is raise both sides to the reciprocal. Because then you'll be invoking your power of a power property that we did back in section 5.2. And power of a power says just multiply your exponents together. If you multiply two reciprocals, then you get an exponent of 1. So you'd be canceling them out. And then you should solve and, of course, check your solutions. Okay, so my first example is quantity 2x to the 3/4 plus 2 equals 10. Okay. Instantly, what do you want to do first? Pretty easy. We got to subtract that 2. That plus 2 can't be over there with my x, right? I'm doing a reverse order of operation. I'm going to undo addition and subtraction. So I'm going to move the 2 to the other side. 2x to the 3/4 equals what now? 8. Okay. Okay, now I'd like to get rid of that 2 that's being multiplied by the x, like through division. But I really can't divide by 2 right now because it's trapped inside the set of parentheses. So I have to undo the exponent first. And if it's being raised to the 3/4, to undo it, I'm going to raise both sides to its reciprocal. So watch very carefully how this is going to work. I'm going to take this whole side, and I'm going to raise it to the 4/3, right? Because that is going to create power of a power over there. And then I would multiply 3/4 by 4/3, which would be 12 over 12, which is just 1, which just gives me 2x to the first, or 2x. Okay, so that's going to cancel it out. But because I raised the left side to the 4/3, now I got to raise the right side to the 4/3. So this is going to give me 2x equals 8 to the 4/3. Now you see why we've been practicing with our flashcards for so long? 8 to the 4/3. Cube root of 8 is 2. 2 to the 4th is 16. Right? Pretty easy for us to do. This is where it gets tricky. This is an odd root, right? So when you do the cube root of 8, there really is only one answer, isn't it? 2. Because then -2 times itself, an odd number of times would be -8. So there really is only one answer there. It's going to be 2 to the 4th, okay, which is 2x equals 16. For sake of notes, I'll put 8 to the 4/3 over here. That's the cube root of 8 to the 4th. That's 2 to the 4th, which is 16. Okay, so you're doing that work. And then last step is divide by 2. So x equals 8. How do I know if I'm right? Just plug it back in, right? So we can do a check here. I'm going to put my check up at the top. Let's see, I'm going to do a little bit of the work. 2 times 8 is 16 to the 3/4, and then plus 2 equals 10. So this is asking me to do the 4th root of 16, which I would assume the positive, 2. 2 cubed is 8. And then 8 plus 2 is equal to 10. Yeah, that works. So it's a good solution. I don't really worry about it. Oh, I guess I could worry about because I am taking a fourth root. Okay. Yeah, I think it's fine. Check it. Okay, let's do some other examples. Let's do 2 times the quantity x plus 2 to the 4/3 equals 32. I definitely put this one in my notebook. Okay, something maybe interesting is going to happen. Get started right now with your groups. Talk to your groups and tell them what things are you going to be doing first to solve for x.
Divide by 2 to start with. And then divide by 2 and then 2.
Excellent. I see a lot of groups dividing by 2 first, right? You don't want to distribute. You actually can't distribute into a parenthesis that has an exponent. Okay, so you actually want to isolate the exponent in its base, x plus 2. So divide by 2. So that gets us what? 16 on the other side. Now I have the exponent and its base all by itself, so what am I going to do to both sides? Power, raise it to the reciprocal. So now it's the 4/3, so I'm going to raise it to the 3/4. Okay. So on this side, again, we get like 4/3 times 3/4 is just 1, so we get x plus 2. Here's where something interesting is going to happen. 16 to the 3/4, what would you generally say? You'd say 8, right? 16 to the 3/4, that's the 4th root of 16, which is 2, and 2 cubed is 8. What if I told you on this one there are 2 answers? Because now I'm not simplifying it, I'm solving it. Like I'm working to solve, right now. And before when I'm checking, I'm plugging a number back in, but I'm just simplifying that side. I'm not actually like, I didn't 4th root both sides. There just was a 4th root or a square root. Okay. But do you see here we're like 16 to the 3/4? I'm solving. So this one is really the 4th root of 16 cubed. And when you take an even root while solving, you don't know if it was positive times positive times positive times positive, or negative times negative times negative times negative. So on this one, we have to say plus or minus 2 cubed. Okay, we're solving right now. We're in the process of solving. That's when you add the plus or minus, if you're solving, which we are. So that means that x plus 2 could equal plus or minus 8. And then we would subtract 2 from both sides. So x equals negative 2 plus or minus 8. One answer is negative 2 plus 8, and the other answer is negative 2 minus 8. So x equals 6 or negative 10. That's what I'm getting. Wait, now I should do what with those answers? I should check them still. So I'm going to check 6. Okay, and I'm going to check 6 in my head here. 6 plus 2 is 8. 8 to the 4/3, that's 2 to the 4th or 16. And 16 times 2 is 32, so that works out, right? Let's put in negative 10. Negative 10 plus 2 is negative 8. Negative 8 to the 4/3, that's the cube root of negative 8, which is negative 2. Raised to the 4th, negative 2 times itself 4 times is positive 16, and positive 16 times 2 is 32. So both answers work. There are two answers, neither one is extraneous. Okay, last example. If I can get this thing. X plus 30 to the 1/2 equals x. What do you suppose you might do? You got a fraction exponent. It's base x plus 30. It's all by itself. Raise it to the reciprocal. What's the reciprocal of 1/2? 2. So I'm going to square both sides. This really could be rewritten as the square root of x plus 30 equals x, right? And then we would undo the square root by squaring both sides. So we'll get x plus 30 equals x squared. What do? Get one side equal to 0. You have x squared and x. You're going to have to factor. So I'm going to do 0 equals x squared minus x minus 30. Do you have factors of 30? Negative 30 that add to make negative 1. Minus 6 plus 5. So x equals 6 and negative 5. Okay, check your answers. So I'm doing what? 36 to the 1/2 equals 6. True? Square root of 36 is 6? Yep, that works. Let's see, this is going to be 25 to the 1/2 equals negative 5. No. 25 to the 1/2, if we were simplifying it, we would say is 5, right? So do you see this is different? I'm not solving this one. I just am plugging it in and trying to simplify it. So I'm not putting the plus or minus. It should be positive. So negative 5 doesn't work. A square root of 25 should equal 5 if you're just simplifying it. So I'm going to cross off 5 or negative 5 and call it extraneous. And x equals 6 is my only answer. Okay, so this requires, not like, there's not a whole lot of new parts to solving it, right? Like the only thing you have to know is like to get rid of a root, raise it to that power, or to get rid of a fraction exponent to raise it to the reciprocal. But what you have to be really careful about are like, what are your solutions? Should I add the plus or minus because I took an even root while solving? Okay. Or am I simplifying when I check it and an even root equal to a negative doesn't actually work, so that's extraneous. Okay, so those are the parts that we're really kind of contemplating that make this Algebra 2 students. Okay, we're better than Algebra 1 because we understand how roots work. Okay. So here's your homework assignment. You can go ahead and get out those books at your pods and get started. And you can work together, solve, check your answers, compare with each other, see if you agree. I'm going to talk to a few people who are absent or need to make up their quiz. So if you know you missed that, be thinking about a time you might like to make that up.